All right, let's just jump right in. Every single engineer faces this fundamental challenge. You've got to make these critical decisions, often with huge consequences, but you almost never have all the information you need. So, this explainer, it's all about how the best engineers navigate that gap, how they decide when they just can't possibly be sure.
We've all been there, haven't we? You're at the whiteboard, you map out a system, and it is perfect. The logic is just flawless, the data flows exactly like it's supposed to, and every little edge case is handled so neatly. It's this beautiful, orderly world. But then, reality comes knocking. And this slide just nails the conflict. On the whiteboard, we've got complete information, clear rules. It's pristine. But in production, the real world, things are messy. Information is incomplete. It's noisy, it's delayed, and sometimes, let's be honest, it's just plain wrong. But guess what? The decisions still have to be made. So, the very first thing we have to do is accept a hard truth. This lack of information, it isn't some temporary problem we're going to solve. Uncertainty isn't a bug, it's a fundamental feature of any complex system. Chasing after perfect information, it's an illusion.
So where does all this uncertainty come from? Well, this slide breaks it down beautifully. You've got partial observability. We can only ever see a piece of the system at once. Then there's delayed feedback, right? The info we get is often stale by the time we see it. The environment itself is always changing. And of course, there's human behavior. Our users, even our own teams, are unpredictable. And finally, you throw all these complex parts together and you get these emergent behaviors that nobody could have seen coming. And that leads to this crucial point. You can't just stand still. Inaction is not an option. A system, or an engineer, that waits around for 100% certainty before making a move is going to be paralyzed forever. The goal isn't to wait for the fog to clear. It's to learn how to navigate through it. And to navigate that fog, we really need the right map. That starts with making a critical distinction that honestly changes everything. We have to understand the difference between risk and uncertainty. So you need to ask yourself this exact question when you're facing a tough call. Is this a situation of calculable risk, or are you truly operating in the realm of uncertainty? Because your strategy has to be completely different depending on the answer. And here's the answer. Risk, that's when you know the possible outcomes and you can actually estimate the probabilities. Think about rolling a die. But uncertainty, and this is where most real-world engineering lives, is when you don't even know all the possible outcomes, let alone their probabilities. This is so important. We are almost always dealing with uncertainty, not just simple risk. Okay, so if we're basically swimming in a sea of uncertainty, how do we make decisions that don't just work today, but actually last? We need a whole different kind of toolkit, one that's built for the messiness of the real world. This slide gives us 3 common models. First up, deterministic. Think of a simple if-then rule, like if CPU is over 90%, add a server. It's simple, it's clear, but it completely shatters the second an assumption breaks. Then you've got probabilistic models. These use stats, Bayesian thinking, all that good stuff to calculate likelihoods. They're incredibly powerful, but also fragile. If your initial probability guesses are off, the whole model can send you in the wrong direction. And finally, we have heuristics, basically rules of thumb, the kind of shortcuts that seasoned engineers pick up from years in the trenches. And here's the really wild part. A lot of the time, those simple heuristics actually outperform the super complex models when things get chaotic. Why? Well, a complex model can be precisely wrong, which can lead to a total disaster. But a simple rule of thumb? It might be less precise, but it's often way more robust. It degrades gracefully instead of just falling off a cliff. This all ties into this really cool concept called bounded rationality. It's just a simple, humble idea. We are not all-knowing supercomputers. Our ability to make any decision is always limited or bounded by the time we have, the info we can get, and our own mental bandwidth. So what does that actually mean for us day to day? It means we have to change our goal. In the real world, chasing that single, perfect, optimal decision, it's often impossible. And worse, it can lead to total paralysis. The real skill of a great engineer is something called satisficing, finding a decision that is good enough, that's robust, and that's safe. So what does a good enough decision actually look like in practice? This slide gives us 3 golden rules. First, make it reversible. Can you hit the undo button? That's your safety net. Second, get fast feedback. Does the decision tell you quickly if you're on the right track? That rapid learning loop is absolutely essential. And third, and this one might be the most important, preserve your options. Does this choice lock you into one path forever, or does it keep other doors open for the future?
This is such a powerful way to think about it. Instead of trying to find the one perfect door to go through, you should focus on the move that lets you choose from the widest range of doors tomorrow. That's optionality, and it's basically a superpower when you're dealing with uncertainty. Now, of course, it's really easy to fall into traps when you're making decisions under pressure. This slide highlights some of the big ones. First, we get obsessed with averages and completely ignore tail risk, that super rare but catastrophic events that can crater everything. Second, we let a metric replace our actual judgment. And third, our confidence just gets way ahead of the actual evidence we have. And finally, we just move too fast, outrunning our own ability to learn and understand what we're even doing. And that leads us to this essential truth. Think about it. An engineer who knows they don't know something, they'll be cautious. They'll build in safeguards. But an engineer who is certain they're right when they are actually wrong, that is the most dangerous person in the room, period. Okay, so let's bring all this together. This isn't just about making better individual choices. It's about a fundamental shift in how we think about our jobs. It's about engineering with wisdom. The first step is just to let go of the old definition. If you think your job is to create certainty, you're going to be frustrated and you're always going to fail. That is not the goal. Instead, our job is this: to act with discipline, with humility, and with responsibility, precisely because we know that certainty is a luxury we just don't have. It's about making the best possible move you can with an incomplete map. And that's the final piece of the puzzle. The goal is not to eliminate uncertainty. You can't. The real goal is to build systems and processes and a culture of decision-making that is resilient to it. We design things that don't shatter, that fail gracefully, that remain safe even when the world throws a curveball. So, I'll leave you with this one question to take back to your own work. The next time you're facing a really tough call, don't just ask, what's the optimal choice right now? Instead, ask yourself this: how can I make this decision in a way that preserves my ability to choose tomorrow?